So now that we have theorem 15, let's see if we can put that to use a little bit. And what we'll do is another example here. We'll take our linear transformation, be from R3 to R2. And we're going to define it a little bit differently here so that we see how we can directly identify with the previous theorem. So again, the transformation can be defined by how it affects the standard basis. So we'll look at the transformation's effect on each of the standard bases values, E1, E2, and E3. And it's defined for us in the problem. So the transformation takes E1 and turns it into 1, 2. The transformation takes E2 and turns it into negative 1, 1. And the transformation takes E3 and turns it into 2, 3. Now, we don't have the specific transformation, but we're going to actually define for ourselves what that is. So one, let's find that matrix of transformation. And then we'll express this particular transformation in both forms that we have. So the actual matrix of transformation is pretty easy to come by here. The matrix A is just going to be what we get when we grab each one of our vectors and throw it into that matrix. The linear transformation being defined by how it affects the standard basis. So we see what happens to each one of these basis vectors as it passes through that transformation, what it outputs. Again, that output is the matrix of transformation. So here we get 1, 2, negative 1, 1, 2, 3. So this becomes our matrix A. We'll represent in part 2 here the transformation using both forms. One being just that A times X is in fact that transformation. So T of X being equal to A times X. So that means that our transformation, T of X, is just going to be equal to 1, 2, minus 1, 1, 2, 3, times a vector from R3, x1, x2, x3. So there's the first representation that we can create. And then just multiplying it up gives us the second representation for what that transformation would look like. So T of X there would then be equal to x1 minus x2 plus 2x3 and 2x1 plus x2 plus 3x3. So in that way, we can use a specific relationship that's given to us to figure out what the transformation is and represent it in both forms.